Hello students and welcome back. So now we are going to talk about one very important aspect in Verilog programming, and that is about operators. We use different operations while programming. So in this video we are going to talk about that what exactly are these operators: arithmetic, relational, equality, logical, bitwise, and shift operators. What are their functions and how to use them? So let us get started. So the first question that we have in our mind is what exactly is an operator? So operators are used to perform an operation, and this operation can be performed on one or more operands, and these are used inside the expressions. Well, then we can ask that what is this expression? Well, we can then ask that what is an expression? Well, expression is going to combine different operands with operators and going to make one desired function. A certain set of operations is performed by a group of operators, and we have different groups of operators. In Verilog, different types of operators are supported and they are grouped together. Now let us talk about these operators according to their categories or the groups. So first of all, we have arithmetic operators, where we have the arithmetic or mathematical functions being performed between one, two, or multiple operands. So the first one is plus, which is for addition, and we use it like y is equal to a plus b. Minus is for subtraction, asterisk sign is for multiplying, slash is for dividing, percentage sign is for calculating the modulo, and two asterisk signs are for exponents. And on the right side we are showing that how to use them for the particular operation. The second category that we have is relational operators. They are used to relate or compare two operands. So we can compare like less than, greater than, less than equal to, or greater than equal to. These operators can be used inside the if conditions also. We can say if a is less than 5 or 5 is greater than equal to b. So these kind of things we can do. These are very helpful in such kind of operations. The next category or the group that we have is equality operators. Here we use them for very specific purpose. 3 equal to signs will be used if a is equal to b, including the x and z values. Remember, we have 4 values in Verilog: 0, 1, x and z. If you want to compare only the 0 and 1 value, then we use 2 equal to's. But if you want to compare x and z also, then we use 3 equal to's. Similarly, exclamation equal to is for not equal to, and it will compare only 0 and 1 values. But if you want to include x and z also, then we will take exclamation equal to equal to. Next we have logical operators. These are for logical operations like and, or, and not. 2 ampersands are used to find if both the sides are combined together with logic and or not. 2 times bars, vertical bars, they are used for or operation, and exclamation is used for not. So these are the 3 logical operations that we perform. Then we have bitwise operators. These are different from the above ones. Now we are computing. Earlier we were comparing. Now we are computing. I want to compute the logical AND of A and B. Then I will use ampersand, only a single ampersand. A vertical bar for OR. Then the power symbol for XOR, and similarly we have for XNOR also, where we combine the tilde signal with XOR signal. So here we will be actually computing and storing the result into a register Y. Shift operators are very important. Sometimes we need to shift our data towards left or right side. So two symbols are used for logical left shift. And if we use 3, then we have arithmetic left shift or arithmetic right shift. So here, when we say A shifted by 2, that means all the values inside the register A will be shifted by 2 bits on the left side. When I say B right shift by 3, that means all the values in the register B, they will shift by 3 bits, and similarly for the arithmetic shift. So students, now we have the good knowledge about the Verilog programming concepts. We are having a module test, and after that we will start our next module with combinational circuit design. Keep learning. Thank you.